Welcome to geometry. The things we talk about in this video are going to be the foundation for everything else we talk about this semester, the building blocks that everything else rests on. It's important that we make sure to define things because we need to make sure that when I say point or line or plane or even sphere or space or object, any of those things, we need to make sure we're talking about the same thing. The tricky part about geometry is that since we start with some basic stuff, there's a point to where we just have to say, we agree that these are the same things. And that's where these three undefined terms in geometry come into play. Because at the end of the day, there are some things that, in a sense, are undefinable. And that's not a scary thing because if you think about it, the word the is really hard to define. What does the word the mean? But it's such a basic building block that we use in our everyday language. It's the same with geometry. When we talk about points and lines and planes, we can describe them, we can talk about their characteristics. It's really hard to give them just a clear, concise definition. So that's what we're going to talk about in this video, and a few definitions that follow from that. But again, this is the foundation. This is the point where we're saying we need to agree on these things so that when we talk about geometry, we're talking in the same language. We're speaking in words that we can understand. Okay, so let's talk about the first undefined term. It's a point. Now, a point, it's just a location. It doesn't have any dimensions. It's like saying you're in the very center point of Austin, right? There's no space, there's no width to that. It just is a place. So a point's a location in space, right? We usually just draw it as a dot, but it doesn't have any dimension. So when we draw it as a dot, it looks as if it does, but really it doesn't have any dimension at all. It has no area, has no volume. And so, okay, so if we want to draw a point, right, our point would look something like this. Oops. Point would look something like this. And these points, we name them by uppercase letters. So we name points by uppercase letters. So this might be point A. I might have another point called, point B, right? These are what points look like. So an example of a point, you could say A, that would be a point, or B, or X. Any uppercase letter. That's how we name our points. Okay, and a point really, I was thinking about this earlier. As far as undefined terms in geometry go, a point is probably the most important one because we use a point to build everything else. Everything else we're going to talk about, we'll talk about in terms of points. So let's talk about a line. Now, a line is different than a line segment. Go ahead and scroll down. Line is different than a line segment in that a line is an infinite number of points extending forever in opposite directions. It has one dimension. Okay, again, a line is just a line. It doesn't have area or volume. It just has one dimension. And so our line might look something like, well, let's get those arrows on there. The line would look something like this, right? That is a line. And if you notice, all of this, everything that makes up this line, maybe you haven't thought about it this way before, those are all points. There's an infinite number of them, right? You could keep zooming in and in and in and in. You would never get to a point where there is no point. Yeah, that works for me. So lines are named by, there's two ways we can name the lines. They're named by lowercase, They're named by lowercase cursive letters. They're also named by 2 points. That's the 2 ways we can name a line. So, for example, we might name a line, we might call this line L. Seems like a safe bet. Or, so we could call it L. Or we might call it line, put 2 points on here. X and Y, could be any letter. So we've got 2 points. We could name it X, Y with a line over the top. And both of those arrows mean that it goes on forever in either direction, past your page, past your room, past your house, right? That line will go on forever, but it's just in one dimension. Okay. A plane. So this is the third and really final point or undefined term for us for geometry. A plane is an infinite number of points that extends forever in a flat manner, has 2 dimensions. So a good, maybe practical example of what a plane looks like would be if you had a piece of paper and extended out forever. That would be a plane. It's not 3-dimensional, it's flat. So a plane, I guess theoretically could have area, even though it's infinite, but it wouldn't have volume. Okay, so let's maybe, if we can draw a diagram here. A plane would look something like this. This is kind of how we draw planes. Imagine that extends on forever, right? That's really a horizontal plane. You could also draw a vertical plane. Vertical plane would look something a little bit more like this, and it is kind of hard to get right. Oops. It is kind of hard to get right on the page, but kind of imagine, you know, that's going vertically out forever. So planes are named by, again, 2 things. They're named by uppercase. Oops. They're named by uppercase, cursive letters. So it's named by an uppercase cursive letter. For example, we might use N, right? Make it fancy. That's an N for the most part, right? It just needs to look fancy. Let's try that again. So N, maybe something like that, a cursive N. Or 3 well, let's say this. 3 points not on the same line. We'll get a term for that later. So 3 points not on the same line, maybe a point here, and a point here. So I don't know, E, F, and G. So my plane would either be N or, again, E, F, G. 3 together like that. That signifies a plane. Okay, so those are the undefined terms. That's what we're going to use. We'll use different types of planes and lines and points, and that's how we'll talk about everything else in geometry. Let's talk about a few other definitions.